Okay, hello. We are ready for notes in Geometry 6-6. First definition, a kite. A kite is a quadrilateral, meaning it has four sides, with exactly two pairs of congruent consecutive sides. Now remember back to, say, a parallelogram. Opposite sides were congruent there. In parallelograms, the left and right were congruent, and the top and bottom was congruent. Notice the difference of a kite. It's now consecutive instead of opposite. So notice your tick marks. These two sides are congruent, so the two sides on the left and then the two sides over on the right are congruent. Well, we have some theorems that go with kites. Theorem 661. It reads, if a quadrilateral is a kite, then its diagonals are perpendicular. So its diagonals from like A to C is diagonal and B to D. That means I can put that little box in the corner to show they are perpendicular. The second theorem reads, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Notice the word one pair. Angle B and angle D would be congruent. However, circle this one, A and C, angle A, angle C, would not be congruent. So it's only one pair. With that said, look at this example. In kite ABCD, the measure of angle DAB is 54. Let's write that in there. DAB is 54. That's that angle right there. And CDF is 52. CDF, so that little small one in there is 52. Find the measure of BCD. B, C to D. What would be that angle measure? DAB is 54. CDF All right, some technical difficulties. Sorry about that. Well, in this problem, remember that I can put a box right there in that corner. And so if I'm talking about this triangle, remember the rule of 180. So 52 plus 90 is 142. And if I subtract 180 from 142, that's 38, which means 38 is that angle FCD, which would mean this angle, this other half, is also 38. And those two 38s combined make angle that I'm trying to find, BCD. So 38 plus 38 is 76. So 76 is the answer I'm looking for. Look at the fourth slide. Trapezoid. So we go from kites to trapezoids. It reads, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides is called a base. Non-parallel sides are called the legs. Base angles of a trapezoid are two consecutive angles whose common side is a base. Of course, you have a diagram. So in this trapezoid, the top and bottom are my bases. They're the ones that are parallel. The left side and right side are my legs. They're not parallel to each other. My base angles would be A and D, would be a pair of base angles. And then also I have the two top angles, B and C. Those would be base angles. Next slide, another definition. If the legs of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. The following theorem states the properties of an isosceles trapezoid. Well, let me show you what an isosceles trapezoid looks like. Which two sides could be congruent? It's the two that are not parallel. You see, your top and bottom could not be parallel because of the way the two legs are kind of bent in towards each other. So isosceles trapezoid, the left and right sides would be congruent. Here are some theorems dealing with isosceles trapezoids. Theorem 663 reads, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. In other words, angle A and angle D are equal, but also angle B and angle C are equal to each other. Now don't confuse that with A and B. A and B would not be congruent. It's just A and D, it's just the two at the bottom, and then B and C, the two at the top. The next theorem, 664. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So it's saying the same thing, just in the other order. Theorem 665. A trapezoid is isosceles if and only if its diagonals are congruent. That means from B to D, that length would equal the length from A to C. And right there it's spelled out for you. AC equals BD. Let's work on some examples. Find the measure of angle A. Well, this trapezoid is really turned on its side. You see the parallel here and parallel there, and yep, it's isosceles. Well, if angle C is 100, that means angle D is 100. Well, remember supplementary. Supplementary would be angle B is 80, which would tell me that angle A is also 80. So my answer is 80 degrees. And I got that because the two angles at the top are the same. Well, in this case, two angles on the right side are the same. And the two angles here are the same. But the consecutive angles going the other way are supplementary. 80 and 100 add up to that 180 magic number. Next theorem. KB is 21.9. Let's go mark that. From K to B is 21.9. And M to F is, that's the whole one, that's 32.7. Find FB. That would just be 32.7 minus 21.9. You would subtract that and get what? I got to borrow. So 17 minus, that's 8. So 0. 10.8. Next slide. Find the value of A so that PQRS is isosceles. In other words, this expression and that expression would have to be what? They would have to be equal. So I'm going to write 2a squared minus 54 equals a squared plus 27. And I would subtract a squared from each side. That gives me 1a squared minus 54 is 27. Then I would add 54 to both sides. So 1a squared would be 81. So what number squared gives me 81? The square root of 81 would be 9. So that's the value of A that makes that an isosceles trapezoid. 3 more slides. Start off with a definition here. Midsegment. The midsegment of a trapezoid is the segment whose endpoints are the midpoints of the legs. In lesson 5.1, you studied the triangle midsegment theorem. The trapezoid midsegment theorem is similar to it. And that's on the next slide. Trapezoid midsegment theorem. Again, in the previous chapter, we did triangle midsegment theorem. Now trapezoid. The midsegment, this theorem reads, the midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the length of its bases. First of all, it's parallel. So I can go ahead and put that arrow on that blue midsegment. But the way all this is worded, it's the sum of 1/2 times. All that means is average. Just average the length of the bases, which means add them up and divide by 2. With that said, look at the last one. Find EF. EF is nothing more than 13.5 plus 8 divided by 2. You average the length of the bases. So that is what? 21.5 divided by 2, which is clear 20. My calculator, 21.5 divided by 2 is 10.75. 10.75 would be the length of EF. Hey, thanks for watching. Good luck on this.